In the 1500s, the scientist Johannes Kepler came up with three laws of planetary motion, and we're going to take a look at those now. I want to introduce you to the first law by taking a look at a simulation of an orbit. I'm going to hit the start button here, and we have the purple planet orbiting the yellow sun in pretty much a circular pathway. Turns out, however, if I stop this, reset it, and I'm going to reduce the initial speed of the planet, hit start again, we still have an orbit here, but it's actually not a perfect circle. This axis is longer than this axis. This shape is called an ellipse, kind of a stretched out circle. In fact, if I stop, reset, and try that again with more velocity, see what happens. Once again, it orbits, it successfully goes around, but not in a perfect circle. Again, this axis longer than this axis, and that's called an ellipse. One other thing you'll notice is that here's where the sun is. It's not dead center. The sun is not dead center and never is dead center in one of these shapes. It's always off to the side. And this location is a special location. It's called the focus. There's another focus over here. And so the plural for focus is foci. The sun orbits at one of the foci. And I'll explain what that is in a moment. So to sum up this observation, we have Kepler's first law of planetary motion, which is that planets orbit in ellipses with the sun at one of the foci. The sun is never at the center of the orbit. Now, all three of these images you see here are ellipses, and you'll notice that ellipses can be very stretched out or almost circles. And so it really brings up the question, what exactly constitutes an ellipse? So here's a little bit of ellipse geometry. And it really gets into how do you draw an ellipse. So I have a YouTube video here that we can take a look at that shows you how to draw an ellipse. You have to put two pins in a piece of paper. Turns out that each one of these pins is at one focus. And you also need a bit of string that you can hang over the paper. So let's see what they do in this video. The thing that makes an ellipse unique, I'm going to turn the volume down here. The thing that makes an ellipse unique is this bit of string is the distance between the two foci and the pen and the other foci. That total distance of those three line segments always stays the same. So as the person uses the pen to draw, the person keeps the string taut. And what naturally happens is the shape that is drawn is the shape of an ellipse. Now, the further apart these two places are, the more stretched out that ellipse is. That's called the more eccentric the ellipse is. The closer together these two pins are, the less stretched out it is, the more circle-like it is. And that's called the eccentricity of the ellipse. So the degree to which it's stretched out is the eccentricity. And the important thing is that those two locations where you put those pins are simply called the foci, or individually they're called a focus. The sun is always at one of those two foci. What's at the other one? Actually nothing. But the important thing is that the sun is at one of those two foci. So that is Kepler's first law of